In the first lesson video on this topic, I defined charge, but I did rather a poor job of it. In this lesson video, I'm going to try to do a bit better because we're going to look at electric fields and how they affect charges. The simplest way to set up an electric field is to have a charged particle. This positively charged particle has an electric field around it, which I'm going to illustrate using field lines. The lines start at the particle, leave its surface at 90 degrees, are evenly spaced, and move away from the positive charge. So they need this arrowhead. The definition of an electric field is this. An electric field is a region in space in which charged particles experience a force. An electric field is a region in space in which a charged particle experiences a force. So, being charged means the particle experiences a force in an electric field. Right, so I promised a better definition of what charge is, but that's not explaining very much still. It's the best we're going to manage though. Particles with charge experience a force in an electric field. In this diagram, if we put a positively charged particle in the electric field, here, we know it will repel. But now we have the field lines, and we can see that the arrow on the field line points in the direction the positively charged particle moves. The direction of an electric field at a point is the direction of the force on a positive charge at that point. We can change the object, creating the electric field, so let's make it a flat plate. And its field lines will be like this. The lines start at the surface, leave the surface at 90 degrees, are evenly spaced, and move away from the positive charge, so they need an arrowhead. This is a good place to summarize what we've found so far. An electric field is a region in space in which charged particles experience a force. Charge is the property of a particle, meaning that it will experience a force in an electric field. The direction of an electric field is the direction of the field lines, the lines of force. And to visualize an electric field, we draw field lines where they leave the surface at 90 degrees. They are evenly spaced. They travel from positive to negative, which means we should put an arrow ahead on them. Back to our plate. If we put another plate over here, this time with negative charge, then the field lines will move towards the negative charge, be evenly spaced, and hit the surface at 90 degrees. This is the electric field pattern between parallel plates, and the arrows show the direction in which a positively charged particle experiences a force. Here's another shape, which is basically what a lightning conductor looks like. We have a point, and above is a flat line representing the clouds. The wind and the clouds rub one another, causing the bottom of the cloud to become negatively charged in a manner similar to the balloon from before. The lightning rod spike is earthed, so it has zero charge, but relative to the cloud it appears positive. So, field lines go from the spike, leaving it around 90 degrees but also being pushed around by the other lines, and entering the negatively charged cloud at 90 degrees. Like this. Make sure there are arrows. What can we see here? Well, looking at the tip of the spike, the field lines are all really close together, and this means we have a really strong field at this point. The strong field can be strong enough to ionize the air, and so lightning strikes. So we've looked at some field patterns and we've defined an electric field which is a region in space in which charged particles experience a force. We've thought about how to visualize an electric field with field lines leaving the surface at 90 degrees, being evenly spaced and traveling from positive to negative, so they've got an arrowhead on them. We've also seen that when the field lines are close together, that gives us a strong electric field, and when the field lines are spaced apart, then we have a weak electric field. There's a lot of maths behind all of this, which we don't really need to look at, but we will look at some of it when we get to A level, and we're also going to see that the maths behind electric fields is the same as the maths behind gravitational fields, and it's the same as the maths behind magnetic fields. So fields have a specific maths behind them, and it's a region in which something experiences a force.